Jupiter, the undisputed giant of our solar system, almost became a second sun. Its immense size and mass are extraordinary. Yet they fall short of the threshold needed to ignite nuclear fusion. Instead of blazing like a star, Jupiter radiates a quiet, internal heat, left over from its formation. But where does this constant internal heat come from? What drives the tumultuous storms and ceaseless winds that sculpt its magnificent atmosphere? Today, let's embark on a journey to uncover the mysteries hidden beneath Jupiter's dazzling clouds, exploring the powerful forces that have shaped this gas giant into a cosmic masterpiece. As you approach Jupiter, the planet reveals itself like a cracked mirror, its surface split into dazzling bands of clouds that stretch across its vast girth. Brown belts and pearl-white zones alternate, forming winding patterns around its equator. These stripes, far from being mere decorations, are the marks of immense atmospheric forces. Jupiter's atmosphere is divided into concentric bands by powerful east-west jet streams, which race at extraordinary speeds, shaping the planet's outermost layers into a dynamic system. In the brighter zones, ammonia clouds rise from the depths, reflecting sunlight with their white and pale gold hues. In the darker belts, we glimpse deeper atmospheric layers, where ammonium sulfide and other compounds dye the clouds in hues of rust red and amber. Each band flows in the opposite direction to its neighbor, as if colossal forces are locked in a perpetual tug-of-war, sculpting Jupiter's atmosphere into bold, distinct patterns. The winds that race through these bands are like nothing on Earth. Wind speeds can soar to hundreds of kilometers per hour, far exceeding the fastest hurricanes or jet streams on our home planet. High-altitude jets can even reach speeds of over 650 kilometers per hour, fueled by centripetal forces generated by Jupiter's rapid rotation. The result is a mesmerizing interplay of light and dark bands, where clouds churn and spiral, creating a seamless, flowing marble of color. But this isn't just a surface spectacle. Deep convection powered by Jupiter's internal heat drives everything. Hot gases rise from the depths, forming towering cloud bands, while cooler air descends, leaving behind clear skies that expose the planet's darker layers. This constant motion sustains the endless atmospheric dance that defines Jupiter's appearance. Amid this swirling chaos lies one of the solar system's most famous features, the Great Red Spot. This massive storm, an orange-red oval in Jupiter's southern hemisphere, has raged for centuries. The Great Red Spot is an anticyclonic system, a high-pressure vortex rotating counterclockwise. Its clouds are rolled tightly into a dense elliptical shape, towering above the surrounding layers. The storm's iconic red hue is still a mystery, though scientists suspect it may be caused by phosphorus-rich compounds or complex organic molecules drawn from the planet's depths. At the storm's edges, wind speeds can reach up to 430 kilometers per hour, twisting clouds into fantastical shapes and creating spirals of white ammonia clouds. First observed over 150 years ago, the Great Red Spot has been shrinking steadily, its diameter now roughly half of what it was at its peak. Even so, it remains the largest storm in the solar system, rotating once every 6 Earth days and towering tens of kilometers above the surrounding clouds. Occasionally, flashes of lightning illuminate the storm's depths, brief yet powerful bursts of energy that reveal the dynamic forces at play. The Great Red Spot, however, is just one of countless storms that dot Jupiter's surface. The planet's atmosphere is alive with turbulence, with small storms and vortices scattered across its vast expanse. Strings of white oval smaller anticyclonic systems similar to the Great Red Spot appear fleetingly. Some storms last for decades, while others dissipate in an instant, their fates determined by the ever-shifting winds. In 2000, 3 small white storms merged into a larger system named Oval BA, which later turned red and earned the nickname Little Red Spot. Fast-moving jets stretch and elongate these vortices, creating waves and ripples at the intersections of light and dark bands. In some regions, Kelvin-Helmholtz waves form, shaped by wind speeds moving at different rates, while dark, boat-shaped clouds drift silently through the jet streams. Bright clusters of clouds, akin to popcorn, mark areas of violent convection, where storms rise from the depths to pierce the upper atmosphere, without a solid surface to disrupt them. These storms can delve deep into Jupiter's atmosphere, living long and raging fiercely in ways Earth's storms never could. The poles of Jupiter offer a different, yet equally mesmerizing, spectacle. In the northern polar region, 8 massive cyclones form a near-perfect octagon around a central vortex. Each cyclone spans 1,500 to 2,800 kilometers in diameter, spinning independently yet bound together in a stable formation. Similar patterns are found at the southern pole, where 6 cyclones form a hexagonal array, rotating with precision and balance. These polar storm clusters have remained stable for years, suggesting the presence of intricate physical mechanisms, perhaps involving fluid dynamics or the influence of polar jet streams. Occasionally, lightning flashes across the polar regions, briefly illuminating the cloud tops with silvery light. Jupiter's lightning storms are far more intense than anything on Earth, occurring at both high altitudes and deep within its atmosphere. High-altitude lightning is a particularly fascinating phenomenon, occurring in frigid layers where temperatures plummet to -88 degrees Celsius. Here, ammonia acts as a natural antifreeze, allowing water to remain in a liquid state despite the extreme cold. During violent storms, hailstones are flung into these upper layers, where they melt and mix with ammonia, forming a slurry that generates electrical charges. The result is shallow lightning brief, eerie bursts of blue and gold that light up the upper atmosphere. Deeper in Jupiter's atmosphere, traditional thunderstorms occur, where water exists in solid, liquid, and gaseous states, mirroring the complex dynamics of Earth's thunderclouds. These storms produce intense lightning strikes, each far more powerful than those on Earth. The Juno spacecraft has detected tens of thousands of such strikes, along with the piercing radio signals they emit, which resonate across Jupiter's immense magnetic field. Above Jupiter's atmosphere lies another breathtaking phenomenon, its auroras. These dazzling displays of light are among the brightest in the solar system, burning with an intensity hundreds of times greater than Earth's auroras. Unlike the brief auroras caused by solar storms on Earth, Jupiter's auroras are nearly constant, fueled by both solar winds and the planet's massive magnetic field. This magnetic field, 16 to 54 times stronger than Earth's, captures high-energy particles and directs them toward the poles. When these particles collide with Jupiter's upper atmosphere, hydrogen molecules become excited, emitting ultraviolet and infrared light. The result is a brilliant display of auroral rings that swirl and dance over the poles. Jupiter's moons also play a role in this spectacle, particularly volcanic Io, which ejects sulfur and oxygen into space. These charged particles are swept into Jupiter's magnetic field, igniting auroras near the poles and leaving glowing footprints. Europa and Ganymede also contribute to this light show, their interactions with Jupiter's magnetic field creating additional auroral patterns. Even Jupiter's faint rings add to its mystique, though they are barely visible compared to Saturn's, discovered in 1979. These delicate rings are formed by dust particles, generated by impacts on small moons like Amalthea and Adrastea. The particles are tiny, most only micron-sized, and they're faint. Ghostly presence is best seen in infrared or backlit conditions. Jupiter is not merely a planet, it's a dynamic system, a symphony of swirling clouds, fiery storms, glowing auroras, and faint rings. Its immense magnetic field, internal heat, and countless moons form a cosmic orchestra of unparalleled grandeur. As we gaze at Jupiter, we see more than a planet. We witness a timeless narrative of transformation, energy, and beauty. A giant still writing the unfinished chapters of the universe in the depths of the starry sea.